Hello students, this is Latif sir. Today I'll discuss about ICSC class 10 chemistry. The topic is acid, bases and salts. The third chapter of ICSC class 10 chemistry. Today I'll discuss about acids. Huh. What is acid and different types of acid. So first I have to say the introduction. I think you have learned in lower classes that what are acids and what are bases. So elements, we know that elements combine in a fixed ratio to form compounds, and compounds can be classified into three distinct classes: acid, bases, and salt. Acid, we know that acid can be identified by their sour taste. The taste of acid is sour, and bases can be identified by their soapy touch, huh, and their bitter taste. And salt is produced salt is the product. Salt is the product formed by combination of acid and bases. We know that we have learned in previous lower classes that acid can be identified by their sour taste, and bases can be identified by their soapy touch and bitter taste, and salt is the product formed by the combination of acid and bases. But it is not possible to test every compounds, whether it is acids or base, uh, because they are harmful. Or it is not also possible always to touch every substances to check these substances whether acids or base, because their acids or bases uh, are harmful to our skin. That's why it is not possible to check in such way. Okay. Acids and bases are recognized by using indicator. So using indicator we can identify whether a substance is acid or a base. A indicator an indicator is a chemical substance which indicates by means of a sharp change in color the nature of solution and their characteristic chemical reactions. So indicators are chemical substances which can change their color to show whether the solution is acid or base. So using indicator you can identify whether a solution is acidic in nature or basic in nature. Lavoisier and Davy studied the terms acids, bases and salt on scientific line, and they state that all acid compulsorily have hydrogen as their constituent element in the form of proton H plus. Lavoisier and Davis state that all acids compulsorily have hydrogen as their constituent element in the form of proton, that is H plus. So acid contains H plus ion, all acids. For example, hydrochloric acid, sulfuric acid, nitric acid, these acids uh, contains H plus ion, proton. Okay, and all bases are either metallic oxide, that is O2 minus ion, or metallic hydroxide ion, or ammonium solution. That is, bases can contain oxide ion, O2 minus ion, metallic oxide ion, or metallic hydroxide ion, that is OH minus ion. Okay. Example of bases are copper oxide, sodium hydroxide, ammonium hydroxide. These are bases. And salts, all salts are chemical compounds. They are formed. All salts are formed by the interaction of acid and base, replacing hydrogen ion present in an acid by metallic ion or non-metallic ammonium ion. Okay, so salts, all salts are chemical compounds. They are formed by the interaction of acid and base, replacing hydrogen ion present in an acid by metallic ion, or sometime by non-metallic ammonium ions. In maximum cases, the metallic ion replace the H plus ion from acid, the metallic ion present in base, which replace the H plus ion present in acid to form salt and water. Example of salt: sodium chloride, calcium carbonate, ammonium phosphate. These are example of salt. Today I'll discuss about mainly acid. Okay, this is the introduction of this chapter, and now I'm going to uh, discuss about acid. So the term acid comes from the Latin word acidus. Acidus meaning sour. In fact, the sour taste of some foods is due to the acid they contain. So in some cases, some food, the taste of some food is sour due to the presence of acid in these foods. Some naturally occurring acids, example of some naturally occurring acids and their sources. Let's see in the box. Acetic acid, which present in vinegar. Citric acid, present in citrus fruits like orange, lemons. Butyric acid, present in uh, rancid butter. Hydrochloric acid, present in our body system, in our body, in gastric juice. Hydrochloric acid is present. Formic acid, sting of bees and ants. Lactic acid, sour milk. Malic acid, present in apples. Oleic acid in olive oil. Oxalic acid in tomatoes. Stearic acid in fats. Tartaric acid, grapes, tamarind, and apples. And uric acid in urine. Okay, these are naturally occurring acid, and their sources also given here in this box. Okay, now I have already told that acids are defined as compound which contain one or more hydrogen atoms. I have told that all acids contain hydrogen atom in the form of H plus, that is proton. So acids are defined as compounds which contains one or more hydrogen atoms, and when dissolved in water produce hydronium ion, that is H3O plus, the only positive charged ion. Generally, acid produces H plus ion, which does not exist in solution, in aqueous solution. Hmm. Which can't exist in aqueous solution, H plus ion, which the initially formed H plus ion from acid will combine with water molecule to form hydronium ion, H3O plus ion. That's why it is written here that acid produce a hydronium ion, H3O plus ion, the only positive charged ion in the solution. For example, HCl, hydrochloric acid, it can produce H plus and Cl minus ion in water. The initially formed H plus ion again combine with water molecule to form H3O plus ion. H plus ion cannot exist independently in the solution. That's why it combine with the water molecule to form H3O plus hydronium ion. Okay. Hydronium ion can exist independently in solution. Hmm. So hydrogen is common in all acids. Other example of acids are sulfuric acid, nitric acid, acetic acid, butyric acid, formic acid, carbonic acid. These are all example of acid. These acids dissolve in water and produces hydronium ion, that is H2O plus ion. For example, in H2SO4, sulfuric acid, there are two hydrogen ion, two hydrogen. So it can produce two H2O plus ion in solution. So when H2SO4 react with water, that is H2SO4 plus 2H2O, produces 2H2O plus SO4 2 minus sulfate anion. Okay. In nitric acid, one hydrogen atom is present. So this hydrogen atom combine with the water molecule to form H2 plus ion and NO3 minus ion. Similarly, in acetic acid, CH3COOH acetic acid, it combine with water molecule to form H3 plus ion and acetate anion. Yeah, that is H3 plus CH3COO minus acetate anion and hydronium ion. So in acid, acid produces H3O plus ion in aqueous solution, which exist independently in the solution. However, for simplicity, we shall use the simplified form H plus instead of H3O plus. Okay. Generally, acid produces H plus, which combines with the water molecule and forms H3O plus ion. Okay. The acidic property of an acid are actually the properties of hydronium ions present in it. Note, in fact, the hydronium ion H3O plus ion can also be written as OH3O plus, since the positive charge is due to the presence of extra hydrogen ion with water, which is neutral. Okay, so H3O plus ion can also be written as OH3O plus. Now, classification of acid. Acid can be classified in different ways. First, depending on their sources, and another classification is depending on the number of replaceable hydrogen atoms. Okay, that is on the basis of their basicity of acids. Okay, so first, depending on their sources, acid can be classified in two classes: organic acids, and second is inorganic acid. Organic acids, which contains carbon, okay, and hydrogen ion. So organic acids which are obtained usually from plants, are called organic acid. They contain carbon atom also along with hydrogen atom. So organic acids, the source of organic acids are plants. Okay, plants, different types of foods. Okay, fruits, oxalic acid, acetic acid, formic acid. These are example of organic acid which contain carbon as one component and hydrogen atom must be present. We know that. Okay. Oxalic acid formula is COOH whole twice. Huh. COOH whole twice. In oxalic acid, two hydrogen atom present. Acetic acid formula is CH3COOH. Formic acid formula is HCOOH. This COOH is the acidic group for organic acid. Okay, in all organic acid there must be present this group, COOH. This is for organic acid, but for inorganic acid only H plus. So organic acid sources plants, and they contains carbon and hydrogen. Example of organic acid: oxalic acid, acetic acid, formic acid, and they are weak acid, and they do not ionize completely in solution. So they contain ions as well as molecules. Only a small fraction of this acid of organic acid will ionize in solution, not completely ionize, form H plus ion, not completely ionized. Okay, that's why they are weak acid. Now inorganic acid or mineral acids. Inorganic acids also called mineral acids. Acid which are obtained usually from minerals are known as inorganic acids. They do not contain carbon. Carbonic acid, which is a mineral acid, but it contains carbon, which is a acid or inorganic acid, but it contains carbon atom. So carbonic acid formula is H2CO3. Generally, inorganic acids do not contain a carbon atom. Okay. Example of inorganic acids: hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. Okay. All inorganic acids are strong acids. They ionize because they can ionize completely in the solution, producing a high concentration of H plus ion or hydronium ion, that is H3O plus ion. Generally, organic acids are weak acids because they do not ionize completely, but inorganic acids are strong acid because they ionize completely in the solution, producing a high concentration of hydronium ion, that is H3O plus ion, or you can also say that H plus ion, high concentration of H plus ion. Carbonic acid is a mineral acid which contains carbon, and it is also a weak acid. Generally mineral acid are a strong acid, but carbonic acid is a weak mineral acid. Okay, it contains ion as well as molecules. Generally, uh, strong acid contains only ions in solution, but carbonic acid, although it is mineral acid, but it is weak mineral acid. It contains ions as well as molecule, unionized molecule. Okay, non-ionized molecules. Sorry, carbonic acid, which contains ions as well as non-ionized molecules. Okay, it turns blue litmus pink, and it is non-corrosive, and it is so used for soft drinks. One point you have to remember that different types of litmus used to identify whether the substances are acids or not, acids or bases. Generally, acids changes the blue litmus to the color of blue litmus to red, and bases changes the color of red litmus to blue. Okay. Now, acid which contain oxygen along with hydrogen and some other element are called oxyacid. So nitric acid HNO3, in which hydrogen and oxygen both present, so it is oxyacid. Sulfuric acid H2SO4, which contain hydrogen and oxygen both, so it is also an oxyacid. And hydracids contain hydrogen and non-metallic element. They do not contain oxygen. So hydracids do not contain oxygen. Example of hydracid: hydrochloric acid HCl, which do not contain oxygen. Hydrobromic acid HBr, not contain oxygen. So it is also hydracid. Okay. Now, second type of classification of acids depending on their basicity. First, you have to know what is basicity. Basicity is the number of replaceable hydrogen ion present in an acid. Okay, so the basicity of an acid is defined as the number of hydronium ion that can be produced by the ionization of one molecule of that acid in aqueous solution. So basicity is the number of replaceable hydrogen ion or number of H0 plus ion hydronium ion produced in aqueous solution of that acid after ionization. Hmm. If two H0 plus ion is produced by the acid, then it is dibasic acid. If one H0 plus ion produced, then the acid is monobasic. If three H0 plus ion is, then it is called tribasic acid. Okay. So first, depending on on their basicity, first type of acids are monobasic acids. Monobasic means one H2O plus ion. So those acids which can produce one hydronium ion in aqueous solution, they are monobasic acid. For example, HCl. When it is mixed with water, one H2 plus ion will produce. So HCl plus water implies H2 plus Cl minus. Initially, HCl produces H plus and Cl minus. The HCl H plus produced will combine with water molecule to form H2 plus ion, because H plus ion cannot exist in aqueous solution. So that's why H plus ion initially formed H plus ion combine with water molecule to form hydronium ion. Similarly, other examples of monobasic acids are HBr, HNO3, HI, acetic acid, CH3COOH. All these are monobasic acid. And we know that acid combine with salt bases to form salt and water. Monobasic acids ionize in one step and form only normal salt. For example, when NaOH is a base, sodium hydroxide is a base which contain OH minus ion, which when NaOH combine with HCl, HCl means H plus Cl minus ion, and NaOH means sodium hydroxide, Na plus OH minus ion. It will form sodium chloride, NaCl, and water. That is salt and water. So monobasic acids ionize in one step and so form only one normal salt. And NaCl, we know that NaCl is a normal salt. Here one point, a note is given in the box. You have to remember that it must be emphasized emphasized here that the basicity of an acid depends not on the number of hydrogen atom in one molecule of that acid, but on the number of ionizable hydrogen atom. I have told before that, yeah, before this point, that number of ionizable or uh, number of ionizable hydrogen atoms, okay, present in one molecule of an acid. Okay, all the hydrogen atom present in one molecule of an acid are not always always are not ionizable hydrogen atoms. Sometimes they are not ionizable hydrogen atom. Huh. For example, acetic acid. There are in this in one molecule of acetic acid, you can see acetic acid formula is CH3COOH, which contain total 4 hydrogen atoms. But all hydrogen atoms are not ionizable hydrogen atoms. Only one hydrogen atoms uh, is a ionizable hydrogen atom in case of acetic acid. And which hydrogen in is ionizable hydrogen atom in acetic acid? The H plus, and the hydrogen atom present in the COOH group. COO portion, the hydrogen atom present in COOH portion is ionizable hydrogen atom. And the hydrogen, 3 hydrogen present in CH3 portion are not ionizable hydrogen atom. That's why acetic acid can produce only one H3 plus ion in aqueous solution. That's why acetic acid, although it contains 4 hydrogen atom, it is a monobasic acid. Now dibasic acids. Di means two. So acid which can produce two hydronium ion in water in aqueous solution are known as diacidic acids. Example of dibasic acids: sulfuric acid H2SO4, oxalic acid H2CO, H2C2O4, sulfurous acid H2SO3, carbonic acid H2CO3. These are dibasic acid, and dibasic acid ionize in two steps. Dibasic acids ionize in two steps. First step, one they produce one H3 plus ion, uh, and in the second step they again produce another H3 plus ion. For example, H2SO4 is a dibasic acid. When it react with the water or combine with the water, it forms H3 plus ion and HSO4 minus ions. Generally, H2SO4 ionize to form H plus and HSO4 minus. H plus and HSO4 minus. The H plus initially formed combine again with water molecule to form H3O plus ion. Okay, so it is generally represented as H2SO4 plus water H2O implies H2 plus plus HSO4 minus. The initially formed HSO4 minus, which again which still contain one H plus ion, one hydrogen atom. That's why HSO4 minus can ionize further to form H0 plus and SO4 2 minus. That's why dibasic acid ionize in two steps, and they produce two H3 plus ion. Similarly, H2CO3 in first step they produce after combining with water, one water molecule produces one H3 plus ion and one HCO3 minus ion. The initially formed HCO3 minus ion again combine with the water molecule to form H3 plus ion and CO3 2 minus ion, carbonate anion. Okay. So dibasic acids have two replaceable or ionizable hydrogen ions. Therefore, they form in the first step they form acid salt, or in the second step they form a normal salt when they are reacting with a base. Hmm. So when a dibasic acid react with react with a base, huh, first step they form a acid salt. In the first step they forms an acid salt. Huh. After releasing one H2 plus ion, one H plus. So NaOH when react with H2SO4, H2SO4 first in the first step one H plus ion from H2SO4 will release, and Na, the product will be NaHSO4 and water. In the second, now NaHSO4 which contains one more H plus ion, which one more hydrogen atom. That's why it can further react with NaOH to form Na2SO4 and water. So Na2SO4 is a normal salt because it does not contain it do not contain any hydrogen, but NaHSO4 is an acid salt because it contains one H hydrogen atom. Now in phosphoric acid, see the box, phosphoric acid H3PO4, which contains three hydrogen atom, but it is dibasic acid because all the three hydrogen atoms are not ionizable or replaceable hydrogen atom. Only the hydrogen atom attached with oxygen in phosphorus acid H3PO3, phosphorus acid. Only the hydrogen attached with oxygen are ionizable hydrogen atom, and the hydrogen directly attached with phosphorus is not ionizable or replaceable hydrogen atom. So in phosphorus acid, that is in H3PO3, two H3 plus ion can obtain in aqueous solution. Okay, that's why the basicity of phosphorus acid is 2. That is, it is dibasic acid. Now tribasic acid, which contains three which can produce three hydronium ions per molecule, per one molecule of the acid, uh, called tribasic acid. Example: phosphoric acid formula is H3PO4, and phosphorus acid mean H3PO3. You have to remember, phosphorus acid is a dibasic acid, but phosphoric acid H3PO4, which is tribasic acid. Citric acid formula is C6H8O7, which is also a tribasic acid. Tribasic acid ionize in three steps. In first step, they produce one hydronium ion. In second step, again produce one hydronium ion. In the third step, they produce another hydronium ion. They ionize step by step. That is, they can release hydronium ion, one hydronium ion in one step. And in tribasic acid, we know that there are total three replaceable hydrogen atom. That's why they can ionize in three steps. And tribasic acid can form, when they react with a base, can form two acid salt in first two step, and one normal salt. For example, phosphoric acid H3PO4, which is a tribasic acid. When it is react with sodium hydroxide in first step, one hydrogen atom will release, that is, in first step the product will form NaH NaH2PO4 NaH2PO4 after releasing one H plus ion, and water molecule. In the second step, uh, it can also produce, if two NaOH sodium hydroxide combine with uh, phosphoric acid molecule H3PO4, then two hydrogen atom will release, then the product will form Na2HPO4 plus 2 water. So Na2HPO4, it is also a acidic also an acidic salt. And in the first case, in the NaH2PO4 is also an acidic salt. Hmm. And if three NaOH molecule combine with one phosphoric acid molecule, then all three hydrogen atom will release. Hmm. Then the product form is Na3PO4, trisodium phosphate, which is a neutral salt. Now, example of silicic acid, his basicity of silicic acid is 4, that is tetrabasic acid. Silicic acid is a tetrabasic acid because it can produce 4 hydronium ion in solution. Formula of silicic acid is H4SiO4. Okay. Now concentration of an acid. What is mean by concentration of an acid? Concentration means amount of acid present in a definite amount of aqueous solution. Concentration of an acid means amount of acid present in a definite amount of its aqueous solution. An acid which contain a very small amount of water or no water is called concentrated acid, while an acid which contains more amount of water, it is dilute solution. If acid contains no water or small amount of water, then it is concentrated acid. And if an acid not contains any water, which contain more water, then it is called dilute acid. Okay. Now, in order to dilute an acid, how to dilute an acid, a concentrated acid to its dilute solution? How to make? In order to dilute an acid, pour acid into water, not water into acid. You have to pour uh, acid into water in small amount and stir constantly. Water is not added to acid as it is an exothermic reaction. It's exothermic process. Large amount of heat will evolve when if you add water to acid. Okay, so it is exothermic process, and in this process, so much heat is produced that splicing of acidic solution may occur. Also, the container may break, which can be fatal to the person due to the evolution of high heat amount of heat. Okay. Now, note concentration of an acid simply tells us the amount of water present in the acid, and not and not at all the strength of acid. Concentration means it indicates the amount of water present in the acid, but it is not tell about the strength of acid. Strength of acid is different thing from the concentration of acid. Strength of an acid is the measure of concentration of hydronium ion produces in its aqueous solution. Thus, dilute HCl solution in dilute HCl is a stronger acid than highly concentrated acetic acid, because dilute HCl is a strong acid which ionize completely in aqueous solution. Hmm. That's why it is stronger acid. While concentrated acetic acid is a weak acid which do not ionize completely and do not produce a high amount of hydronium ion. Yeah, concentration of hydronium ion is low in case of highly concentrated acetic acid solution, but concentration of hydronium ion is very high in case of dilute hydraulic acid. That's why dilute hydraulic acid, hydrochloric acid. That's why dilute hydrochloric acid is stronger acid than highly concentrated acetic acid. Another note: the strength of an acid depends on the degree of ionization of the acid and the concentration of hydronium ion produced by that acid in aqueous solution. And degree of the ionization is defined as number of acid molecule ionized by total number of acid molecule present in the aqueous solution into 100. Huh. For a concentrated acid, strong acid, the number all the acid nearly all the acid molecule present in the solution will ionize. That's why degree of ionization for a strong acid is almost 100%. Huh. But for a weak acid, the degree of ionization l- is very low. Hmm. If the degree of ionization of an acid or alkali in aqueous solution is greater than 30%, then it is taken as strong acid or a strong base. If the degree of ionization is less than 30%, then it is taken as weak acid or weak base. Thank you.